Good morning, students. Today's session we are going to discuss about on the stack data structure. So I am Dr. P. Pichemanikam from Department of Computational Intelligence. So we are going to discuss about the stack data structure. So the data structure is one of the important aspect of the computer programming and the implementation of the several applications. So in this session, we are going to discuss about the stack applications, stack operations, and how we are going to implement the stack using arrays as well as the linked list representation. Next one thing is introduction. Introduction to the stack. So here the stack is the linear data structure which is used in the which used to follow the principles of last in first out principle. And here the stack has one end. So here we are not to insert we are going to insert an element or delete an element inside the inside by using only one end, but there is a one pointer is there. That pointer is called as an the top pointer. Whenever the element is added into this in the stack, there should be add, just we just increment the top of the stack and just insert an element, and suppose the element is deleted from the stack also. Another one more thing is what are all the operations of the stack. So here suppose if we are implementing this the stack, we are going to perform the following operation. So first one thing is push operation. So we need to add an element on the top of the stack. Okay. So suppose if you want to insert an element on the top of the stack, only with the help of this the push operation. Next one thing is the pop operation. It removes the topmost element for the stack. So it should remove the topmost element by referring that the stack pointer. Another one more third option is empty. So by using this method, we just check whether the stack is empty or full. Okay, so whether the stack is empty, suppose if you want to do the insertion process as well as the deletion process, we need to check the behavior of the stack. If the stack is empty, so we are not able to delete any kind of element. Suppose if the stack is full, we are not able to insert an element. So that's what we need to consider, these two constraints. We need to check the behavior of the stack with the help of these two functions, is empty and is full. Next one thing is display function. So display of the top of the element in the stack. So these are all the stack operation. And next one thing is the two important operations are that one is the push operation. Another one more thing is the pop operation. The push operation is that there is we need to consider the pseudocode. The first one thing is we just check the behavior of the stack, top of the stack pointer. That is equal to n means when the stack is full, or otherwise we need to consider the top is equal to top plus one. That is the top pointer, the stack pointer, that should be incremented by one, and the process is over. So we need to assign the item on the top of the stack. So this is the way we need to perform the insertion operation in this on the stack. Suppose consider this example. So initially the value of the top pointer is equal to -1. So after that, I am just inserting an element into the stack is push operation. So I want to insert an element 10 into the stack. So I just increment the stack pointer by 1. So I just add the value of 1 in the top of the stack pointer. Already the top value is equal to -1. So -1 plus 1 is equal to 0. So the top value is equal to 0. And after that, I just insert an element as 10 into the stack. So again, I want to insert an element is push an element is 20. So what we are going to do that. So again, already in the previous case, the top value is equal to 0. Now again, I want to insert an element by 1. So it should be inserted as an 20. That is top is equal to 1. And again, after that, I want to insert an element into the stack. So this is a push operation. So once if we are following this kind of methodology, we are able to easily insert an element into the stack. Next one important thing is the time complexity. So what are all the ways we are going to consider the time complexity? There is an order of one. We just insert only one element in the stack for incrementing the top pointer. So the time complexity is order of one, and that's all about this the push operation. Next, we are going to discuss about the pop operation. So what about the pop operation? So we need to consider the explain the pseudocode. So first, we need to consider the top as equal to 0. So that is the stack is empty. So we just take the stack the empty. Suppose if it is condition is false, so we just move it on the else part. So the stack of the top element that should be assigned in that item, and the top is equal to top minus one. So this is the way we just inserted. So consider this example. So initially we are having this the top value is equal to 1, and we are inserting the two different element 10 and 20 is inserted in the stack. Now we are going to pop the element. So pop the element is 20. So how we are going to do that? We just decrement the already in our stack. There are some elements are available. So it is not an empty. So the top value the top of the stack pointer is equal to 1. So if the condition is false, so we just move it on the else part. So we just take the top of the stack value is equal to 20. So that should be stored it in an item. Again, I want to decrement the pointer top is equal to top minus 1. So I just decrement the pointer top is equal to top minus 1, and here top is equal to 0. So 10 is there. So the top complex time complexity is order of 1. So this is a representation of this push and pop operation. That's all about the array representation of the push and pop operation. So again, I want to represent the linked. There is another one representation is called as a linked list representation. So how we are going to linked list representation. So here we just represent one node. The node may have the two different fields. One is called as an data. Another one is called as an the operator, the pointer that points to the next operator, next pointer. So again, we need to insert a next element, and we just insert an element. So this is the way we need to insert an element into the stack. Okay. So here we just insert one more element. So after that, there is no further representation of the pointer. So we just stop it. So first one thing is we just represent the node, the struct node, and we are having the two different fields. One is the data. Another one more thing is and the struct node into star. So this is a linked list representation. So after this, so how we are going to perform the push operation in the stack? So how we are going to do this? So here first we just declare the structure, the representation of the node. After that, we just check the pointer. If the pointer is equal to null, we are not able to push the element. Suppose after that, if you are if the element if there is some elements are there, so we just get the value from the user side. So after that, we need to check if the head is equal to null. So after that, there is pointer tends to data is equal to value, and pointer next is equal to null, and head is equal to pointer, or otherwise else is equal to pointer tends to data is equal to value, and pointer tends to next is equal to head, and head is equal to pointer, and the item is pushed. Okay, consider this scenario as example. First, I just this is some sample. Suppose there is a 10, 20, and 30. These are all the elements are inserted into the linked list. Suppose I want to insert an element into 5 in the node. So first, I just move the head pointer to this the node value, and again on the structure pointer that points to the header pointer. So I just change it. So if we swap these two links, automatically we just insert an element into the stack. So this is a single linked list representation of the stack with the help of this the push operation. Another one more thing is called as the pop operation. So what about the pop operation? So we need to delete an element from the stack with the help of this the linked list representation. So int item, so struct node star pointer. So here we just check whether the head value is equal to null. So automatically we just perform the underflow, or otherwise we just perform the item is equal to head tends to value, or head is equal pointer is equal to head, and head is equal to head order next. So the free pointer and item is popped. So here For this example, if I want to delete an element 5 from the stack, so I just change over the pointer here. So here, there is automatically directly I just represent these dotted lines that should be removed from this the linked list representation of the stack. So the head pointer directly points to the next element of the stack. So automatically it points to the element of 10, 20, and 30. So this is a linked list representation of the stack with the pop operation. So next one thing is the display operation. So how display operation means how we are going to display the number of elements in the stack. So this is our idea. So first we just see the example. So consider this example how we are going to do this. First, this is a head. So how we are going to do this? Suppose the three nodes or three elements are stored in the stack 10, 20, and 30. Suppose how we are going to retrieve this. So first we just declare the struct node star pointer, and the pointer is equal to head. So if pointer is equal to null, so the stack is empty. So we are not printing any kind of element from this. Suppose if the pointer is not equal to null, so we are going to print the element in the stack. So we just check the pointer not equal to null. So again, that is we just print the value of pointer tends to value. So and again pointer is equal to pointer tends to next. So we just move the pointer to the next position for reading the successive value of the stack. So this is the pseudocode for displaying the operations. That's all. Thank you so much.